Today I'm going to talk about what is the queue in data structure and application of the queue data structure using queue in Node.js. What is the call stack and event loop and type of the callback queues. Those are topics I'm going to introduce. What is queue? Queue is a functional foundational data structure used in programming applications. It is an abstract data type or a linear data structure that stored the element sequentially. Queues are typically used to manage threads in multi-threading and implementing priority queuing systems. Queue is an important data structure in programming. Queue follows the first in first out method and is open at both of its ends. Instant is done at one end rare and end or the tail of the queue, while deletion is done at other's end called front end or head of the queue. Like example of the queue data structure is line of people waiting to buy a fuel at a petrol shed. A new person will join the line from the end and the person standing at the front will be first to get the fuel and leave the line. Similarly, in the queue data structure, data added first will leave the queue first in first out method. Same as real life examples are car wash queue, bank queue and gas queue. There are 4 different queues in the data structure on simple queues, circular queues, priority queues and double-end queues. Simple queue means it is the most base queue in which the tenth of an item is done at the front of the queue and detection takes place at the end of the queue. In a circle queue, the last node is connected to the first node. It is also known as ring buffer as all the ends are connected to another end. Intention stays at the front of the queue and deletion at the end of the queue. In a priority queue, the nodes will have some predefined priorities in the priority queue. The node with the best priority will be the first to removed from the queue. Instantiation takes place in the order of the arrival of the nodes. In double-end queues, instant and deletion can take place at both front and rear ends of the queue. Now, basic operations of the queue in data structure: enqueue and dequeue and peak, initialize, full and it's empty. Those are the operations of the data structure in queue. Enqueue is the process of adding or storing an element to the end of the queue. Dequeue is a process of removing, accessing an element of the front of the queue. Peak means it is used to get the element at the front of the queue without removing it. Initialize means create an empty queue. Is full is it takes queue is full. Is empty means check the queue is empty or not. Queue can be implemented in two ways. One way is sequential allocation and second is linked list allocation. Sequential allocation, it can be implemented using an array. Queue implement using an array can organize only limited number of elements. In linked list allocation, it can be implemented using linked list. Queue implement using linked list can organize an unlimited number of elements. Now we discuss application of the queue in data structure. When resources is shared among multiple consumers, example as include CPU scheduling, disk scheduling. When the data is transferred asynchronously between two processors, example pipe, output buffers, IO buffers. In operating systems, tampos and save scheduling and spool in printers, buffer devices for like a keyboard or some devices, and in networks using routes and switches, mail queues. Now we discuss queue in Node.js. There are common scenarios. Application will have a lot of workloads that should be processed asynchronously from application flows. Those asynchronous operations may contain synchronous actions within them too. This easily shows common issues to handle in Node.js, but we use as a technique in Node.js. We can easily effectively handle asynchronous operations. Data structure can be defined as the group of data elements that provides an efficient approach to store and organizing data in the computer so that it can be retrieved and and used effectively. A queue is also a linear data structure. Linear data structure have data elements arranged in the orderly. Each member is connected to its previous and next sibling element. This connectivity between the elements help to describe the linear data structure in a single flow and in a single run. Queue is a linear data structure used in Node.js to appropriately and progressively organize asynchronous operations. These and asynclic operations where sync operation is instead at the end of the queue and it's removed from the off queue. Those operations exist in different forms, including HTTP request, read or write file operations, streams, and more. Handle asynchronous operations within Node.js application can be during to manage. JavaScript function like native time and other asynchronous operation can take an indefinite duration to complete their asynchronous operation, but with use we handle asynchronous operation synchronously by inserting a new element and removing an existing element on the array. The call stack event loop and implement the queue within the program. Call stack JavaScript engine uses call stack to manage execution context, the global execution context and functional execution context. The call stack work based on last in first out principle. When we execute a script, the JavaScript engine create a global execution context and push it on top of the call stack. When a function is called, the JavaScript engine creates a function execute context for the function, pushes it on the top of the call stack and starts executing the function. If a function called another function, the JavaScript engine creates a new functional execution context for the function that is beginning called, pushes on top of the call stack. When the current function completes, the JavaScript engine pops it off the call stack and resumes the execution where it left off. The script will stop when the call stack is empty. Now, when the JavaScript engine executes this script, it places the global execution context function in the call stack main. The global execution context enter the creation phase. It moves the execution phase. The JavaScript engine executes the call to the average function and create a function execution context for the average function and pushes into the top of the call stack. JavaScript engine start the execution average, so its average function is on top of the call stack. The average function calls add function. At this point, the JavaScript engine creates another function execution context for the add function and places into the top of the call stack. JavaScript engine executes the add function and pops it of the call stack. At this point, the average function is on the top of the call stack. JavaScript engine executes pops it off the call stack. Stack is empty. Script is stop the execution. Event loop is what's allowed Node.js to perform the non-blocking IO operations, despite the fact that JavaScript is single-threaded, by offloading operation to the system kernel whenever possible. Diagram is about the event loop. It has a stack heaps callback queue. Stack is where all your JavaScript code gets pushed and executed one by one as the interpreter reads your program and gets popped out once execution is done. If your statement is synchronous, timeout, check promises, click event, then code goes to forward to event table. Table responsible for moving your asynchronous code to callback event queue after specific time. This is where all the memory allocation happens for your variables that you have defined in your program. Callback queue where your asynchronous code gets pushed to and wait the execution. Then comes the event loop, which keeps running continuously and check the main stack if it has any frames to execute. If not, then it callback queue. If callback queue has code to execute, then it pops up the message from it to the main stack from the execution. Apart from callback queue, browsers have introduced one more queue, which is the job queues received only for new promises functionality. So when you use promise in your code, you can add then method, which is callback method. Those denable methods are added to the job queues once the promises has returned result and then gets executed. The event loop is the secret behind the JavaScript synchronous programming. JS execute all the program operations on single threaded but using few smart data structure. It gives illusion of the multi-threading. The call stack is responsible for the keep tracking of the operations in the line to be executed whenever function is finished from the stack. The event queue is responsible for sending new functions to the stack for processing. It follows the queue data structure to maintain the correct sequence in which all operations should be sent for execution. Whenever an async function is called, it's sent to the browser API. Those are APIs built into the browser based on the command received from the call stack. The API starts its own single thread operation. An example of the set timeout method. When a set operation process is in the stack, it is sent to the corresponding API which wait till the specific time to send this operation back to process. The event queue send the operation. We have to cycle system for running sync operation in JavaScript. The language itself single threaded, but the browser API act as a separate thread. The event loop facilitates this process. It's continuously check whether or not call stack is empty. New functions are added from the event queue. If it's not, then current function called is processed. We talk about callback queues. 5 callback queues are there: microtask queue, timer queue, IO queues, and check queue, and close queues. Microtask queue. In this type of callback queues, we continuously using the event loop to keep checking the queue for delayed function before processing to the queues. Queues is first in, first out, task first run and first. We implement this within 2 different functions. One function is process next tick and promise process next. This is function that would execute a different function within the queue at every next tick. Iteration of the program, those structure of the microtask queue, storing those functions makes it easy that they can be executed at every next tick. The first queue holds this function. Promises. This present the eventual completion and operations. Promises handle is always asynchronous as all the promises action pass through the internal promises jobs queue, also called microtask queue. Timer queue is provided with a timer module containing functions that execute a program after a set period of time. This provides us with the means to have time-related operations are asynchronously in nature. The event loop goes on executing all synchronous operations within the program, then returns to the callback queue only when all the synchronous operations have been completely executed to execute the asynchronous operations. IO queues. Here we are dealing with operations that involve interact with external environments outside our internal program. Those operations are asynchronously handled by Node.js after the synchronous code has finished running. Example, those operations including read and write file operations, network operations, and other operations that reach outside your program to fetch data for use within your program. IO callback queues transfers the operation to the event loop, which in turn transferred to the call stack for execution. Check queues. This queue allows to immediate execute of the callback queue immediately after the callback function in the IO queues have been executed. Within this, we continuously check the call stack if became idle and scripts have been queued with set immediate. The event loop may continue to execute the check callback queues rather than waiting. Set immediate is actually a special timer that runs the separate phase of the event loop. It uses libuv API that schedules callback to execute after pool race has been completed. Finally, close queues. These queues stored functions that are associated with close event operations. One example is stream, an abstract interface for working with stream data in the Node.js. For instance, for stream close event, which is emitted when the stream has been closed, significant that no more events will be emitted, and HTTP close event, which is emitted when the server closes. Now it's done.